Chapter 2. Today we are going to start the first lesson on functions. But before we do that, let's cover a couple of things. You should have watched the video about graphing and making tables in the TI-84 calculator. If you haven't done that yet, you might want to do that now before you start. There's a couple of things that are going to be different in Chapter 2. Instead of a resource page, you now have a lesson page that's actually going to be 3 or 4 pages. If you can print that lesson file, it's a PDF, then you should stop the video and go ahead and do that. If you can't print, that's fine too, but you're going to need notebook paper and you probably will need graph paper or at least a straight edge. We're going to do a lot of graphing in this lesson. So if you want to pause and get set up for that. All right, what is different in Chapter 2? Well, we are, in addition to the lesson copies, replacing the resource pages, you're also going to have the practice for these lessons for Chapter 2 will be in Schoology instead of on the eTextbook site. And there'll be some different ways that you'll be able to check your work. What is in Chapter 2? Chapter 2 is all about functions. The function that you've worked with so far, sorry about that, has been a linear function.
Dine in, Blue Day, group you are dismissed in the cafeteria. Dine in, Blue Day.
That's what it sounds like if you're here during third block and we're going to lunch. Sorry about that. We grab the time when we can. So we're going to be able to describe functions. We're going to be able to identify functions. We're going to work with function notation. And the first thing we're going to do today in this lesson is learn how to read a graph that involves a function. So hopefully you can see this now. This is describing graphs, lesson 2.1. We have some vocabulary. Some of it is review. Hopefully you know what an x-intercept is. It's where the graph crosses the x-axis. You should always write x-intercepts as ordered pairs. They start with an x value and they end with 0 because that's what the value of y is on the x-axis. Y-intercepts mean that, or they are where the graph crosses the y-axis. So this time we're the other way, we're on the vertical line, and all y-intercepts are written as ordered pairs. The x value is 0, and then you have the y value where it crosses the axis. Here's a new word, a vertex. A vertex is the highest or lowest point on the graph, and the vertex is an ordered pair as well. It's going to be an x and a y. Now, a lot of the graphs that we're going to look at today are shaped in something called a parabola. You may have heard that word before. A parabola is a symmetric U-shaped curve. It has a line of symmetry that passes through the vertex. And we'll talk about what symmetry and all of that stuff means in just a minute. But we're going to look at this graph very closely. Right here, the one that's shown. It is the graph of a function that is y equal x to the third power minus 9x. And here's my first question. How do you read a graph? You read a graph just like a book. You read a graph from left to right. Let's make sure the pen is functioning. And there we go. We read from left to right. All right, if this graph were on a screen that you could zoom out on, like a calculator screen, I could zoom this one out, but I'm not going to because it would mess up what you're looking at. Could you find where this graph starts and stops? It's not a trick question. This graph, there's a point right here and a point down here, but that isn't where this graph ends. If I made this grid bigger, right now it's a 5 by 5, actually that's 12, this is 5 by 5 and 12. If I made this grid bigger and made it by 1,000 by 1,000, this graph would still be here. Because what this means, if it comes to an end here where the grid is, it means that this graph has arrows on the end. And it actually goes to infinity. So let's put some arrows on your graph. All right, now we're going to explore the graph. And the first question, and the questions follow in the same order through the whole lesson. The first question is, what is the shape of this graph? Well, you look at it, and if you tip your head sideways, it sort of looks like an S. Depending on which way you tip it sideways, it's a backward S. But in the world of math, what we have here, if you look up here, we had a parabola was a symmetric U-shaped curve. Let's change colors and underline that. A symmetric U-shaped curve. All right, so what we have here are two parabolas. And the first one is right here. Let me erase all this in a minute. And the second one is right there. So we have two parabolas or we have a double parabola. Let me erase that because we're going to actually write some more stuff on this graph that we need. So the shape, and you're writing notes down, of this S shape is actually officially known as a double parabola. All right, the next thing we're going to look for are the x and the y intercepts. All right, the x-intercepts, every place it crosses the x-axis. So I have an x-intercept right here. I have an x-intercept right there. And I have an x-intercept right there. All right, in the box, or if you printed, you have a box, but on your notebook paper, what I want you to write are the ordered pairs for those x-intercepts. This one, the first one, is -3, 0. The one in the middle is the origin, so it is 0, 0. And the one over here on the side is 3, 0. So x-intercepts all end with zeros, and they start with the x value where it crosses the x-axis. All right, now we're going to look for y-intercepts. This time we're looking along the y-axis. So if I look here, there is one place where this crosses the y-axis, which is right here. And it's right there. So this origin this time, because the graph crosses it at the x-intercept and the y-intercept, we have the x-intercept and the y-intercept are exactly the same for that point. All right, the next question as we work down through this list is there a vertex? All right, what we set up here, we said that the vertex was the highest or lowest point on the graph. This graph does not actually have a vertex. Not everything is going to have all the components that we asked for. So in this case, there is no vertex for this graph. Okay, the next question says, is there a maximum or a minimum, and if so, where? Let's erase some of this again so you can see this. Okay, the maximum or the minimum. Maximum and minimum are up or down. They're not left or right. If I'm looking for the highest or lowest, I'm looking up or down. So I'm looking along the y-axis. So the highest value I have in this graph for a maximum is right here. And that's not okay. So I'm going to draw a line across here. That's the wrong color. There we go. I'm going to draw a line right here, and I hope I can well, I did that already. I don't know why it didn't take. Okay. I've got a dashed line I'm going to draw along here. And I'm going to go ahead and find the y value for that line. And the y value right there is between 9 and 12, so halfway in between, tells me that I have a local maximum It's not an ultimate or a single maximum, but it's a local maximum at y is equal to 10.5. All right, now, usually I only have one. I have one maximum or I have one minimum, or I don't have either one. But in this case, I've not only got a local maximum, I also have a local minimum right down here. So we'll draw a dotted line across there. And this time, this point right here on this graph is a local minimum at y is equal to negative 10.5. All right, does the graph have symmetry? Can I fold this graph in half, and do I have a mirror image? And the place I have to fold in half is somewhere on a vertical line. And I can't have a vertical line anywhere on that graph where I can fold this in half. So this graph does not have symmetry. It is not symmetric. What is the first value for the x's? Let's look at that. And erase everything. That's faster. The first value for the x's, I'm going to read it from left to right again. So starting over here, remember we had arrows down here. So coming along and reading this from left to right, if I look very carefully, this graph started down here at infinity. So the first value for x, the first x value is infinity. And if I keep moving along here to all the way from left to right, this is where this graph ends. That's the last value, last x value. All right, now I'm going to do the same thing. I'm going to look for the first and the last values for y. But we don't do that from left to right. If you'll notice, we went from negative to positive. So we're going to do the same thing when we look for the y's. We're going to start down here where the y's are negative and move to where they are positive. So the first value that I find for y, starting down here at the bottom, again, is an infinity. So my first y is infinity, and my last y, going from the bottom all the way up here, is that same infinity. I know this is confusing, but we're going to do it enough times it'll make sense. All right, two more questions. As the x values increase, what happens to the y values? All right, the x values don't do anything but increase. I read from left to right. Going from left to right, I go from -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. They just increase. They don't do anything else. So what I'm interested in seeing is what happens to the y values. So from left to right, my y values from here to here went from somewhere from infinity up to, what did we say that was, 10.5? And they increased. So the first thing they did was increase. And then I reached this point, and they started coming down, and they decreased. And then I go out here, and they increased again. This is what the y's are doing. The x's are just increasing. All right, one more question. Does the graph open up or down? This particular graph goes up and down and up again, so this graph does neither one. Put the word neither, or you could say it doesn't open up or down, something to that effect. So that's our first graph, and let's go ahead and check your answers before we move along, because I know this is difficult to do this, to look at the graph and take notes at the same time. Here's the answers at the bottom of my page. So that's everything we wrote down. The parabolas, the intercepts, whether there was a vertex, symmetry, where the graph started and stopped, left to right, increasing and decreasing. And if you haven't been able to take great notes, this file with everything written on it will be available tomorrow, so you can compare your practice answers as well. All right, next one. And I think we're about to have another interruption. Okay, we are now going to look at a different graph. It is y is equal to x squared. And we've got a box up there that says the domain is all possible input values for a function. So what we want to know here is what would be possible input values for this function. It's the question right here at the top. Okay, so what we're going to do to the x values here, we're going to square them. We're going to multiply it to itself. So are there any numbers, positive or negative, rational, irrational, that can't be multiplied to themselves? No, I can multiply all the numbers that I know to themselves and I will get an answer. So the answer to this question is, what would be possible input values for this? I could use all real numbers. All right, now we're going to build this table. And if you watch the calculator video, you are going to go ahead and you're going to press your y equal button and put x squared in at y equal. And then you're going to go ahead and press my second and graph and fill in your table. If you haven't watched the calculator video, it's okay. We can move forward. That's what this center part is for. So if I fill this in, you'll notice that there are parentheses right here. Because anytime I'm going to substitute anything into a function, I'm going to put parentheses around it or I'll get the wrong answer. So let's go ahead and fill in this table. And if you're using your calculator, you're going to go ahead and start filling in the y values from your calculator. If you're using a regular calculator, go ahead and fill in this table and start putting your y values off to the side. That's what it would look like if you did it correctly. All right, so negative 4 squared is negative 4 times negative 4, so it's going to be a positive 16. Negative 3 times negative 3 is a positive 9. Negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1, 0, 1, 4, 9, and 16. That was sort of interesting to see how we got the same answers as we moved around that. All right, let's see if I can graph this on this board, because you know how the writing is difficult. Put the points on first. So I've got, let's see, I've got a negative 4 and 16, which is a problem because my y-axis doesn't go to 16. It only goes to 10. So I'm going to skip that one, and I'm going to go to this one, negative 3 and 9. And I know that one is right there, so I'm putting that dot there. And then I've got a negative 2 and 4. So I'm going over to negative 2, and I'm going to mark that one. And 0, let's see, negative 1 and 1 is right here, sort of. And 0, 0 is right here. That got a little better. And here's 1 and 1. 2 and 4, and 3 and 9. All right, this is going to be a parabola. It's going to be a nice smooth curve, and hopefully you can draw it better than I'll be able to on the screen. It is not a V shape. Do not draw a V shape. It is a U shape. So even if I end up with something pointy at the bottom here, keep that in mind. This is not a V, it's a U. So I'm going to start trying to connect these lines. Not too bad so far. And remember that the grid stopped, but the graph didn't, so we're going to put arrows on the end, and that's not too bad. All right, hopefully you've drawn your graph. If you haven't, pause the video, and then you can draw it and come back and rejoin us. Let's start answering our questions, the exact same questions we asked before. And what is the shape of this graph? This graph is a parabola. So somewhere down there, say that that's the shape we've got. It's a parabola. asked me about x and y intercepts. Remember, x-intercepts are where the graph crosses the x-axis. Well, it didn't actually cross right there, but that qualifies where it touches right here as an x-intercept. So we're going to say we had an x-intercept at 0, 0. Put parentheses around it. It's an ordered pair. All right, where did it cross the y-axis? Same place. Here's the y-axis coming down this way, and it crossed right there. So my y-intercept is also 0, 0. Okay, remember from the vocabulary, the vertex was the highest or lowest point on the graph. All right, the lowest point on this graph is right there. Erase this because it's too much stuff. The lowest point on this graph is right here. So that tells me that I also have a vertex right there. And that vertex is 0, 0. So the fact that these are all exactly the same ordered pair is not an issue. The x-intercept, the y-intercept, and the vertex are all 0, 0, but they all meet the requirements for their definition. X-intercept crosses the x-axis, y-intercept crosses the y-axis, and the vertex is the highest or lowest point on the graph. All right, next coming up. So, is there a maximum or a minimum? Let's erase a little bit here so you can see what we're talking about. Okay, the maximum, again, is going to be up or down. Minimum is going to be up or down. So we're looking for the lowest or highest place on up or down. And what we're going to find that is right here. And this time we do have a single minimum. And this minimum is at y is equal to 0. You always state the maximum and the minimum in terms of the y. Does the graph have symmetry? Absolutely, this graph has symmetry. And I'm going to show you, even this works out really well with this one. Okay, we're going to erase some of this because we don't need it. And I'm going to show you if I fold this graph in half, right along the y-axis, this graph is a mirror image. So this graph has symmetry. I can fold it in half right here on the y-axis. And it would be a mirror image. This side, on this side, would touch this side exactly where it is. So it has symmetry. Put symmetry as yes. It is symmetric. And the place where I can fold this in half is right here. And that is where x is equal to 0. That's my fold line. All right, now we're going to look for where do the x values start and where do they stop. You can always pause and rewind and everything else if I'm going too fast. Keep that in mind. Yeah, the little eraser takes a lot of time. Get rid of some of this. All right, we're looking for where the x values, the first x value is and where the last x value is, and where the first y value is and where the last y value is. All right, so from left to right, if I come along here and I'm looking for the first time I have an x value, and the first place I have an x value is up here, and so my first x value is at infinity. And if I keep going along with that graph, my very last x value is right up there. So my last x infinity. Now, to look for the y, where it starts and stops, I go from bottom to top. Everything is from negative to positive. Left to right on the x's is negative to positive. Bottom to top on the y's is negative to positive. A lot of little tracks all over. There we go. All right, so we're going to start at the bottom to find the first and last. Now, do I have any y values whatsoever down here in the bottom? I don't. There are no y values down here in the negatives. None at all. The very first y value I find is right there. So my y's start, my first y is at y is equal to 0. That's the very first y I find. And then if I keep going looking for my last y, I keep going from bottom to top, my last y is at infinity. Lots of infinities, but can you see how we start reading this from one side to the other and then from bottom to top? All right, what is it doing in terms of increasing and decreasing? So, let's look at the y values again. The x values are interesting, but the x values only increase. They don't do anything else. From left to right, the y values march all over the place. All right, so, I do have an orange. All right, left to right. Let's take a look what's going on here. So I come along here, and it didn't turn orange. There we go. I come along here with my x's, and this is what my y's are doing. First, my y's decrease. And then they hit this 0, 0, and then my y's increase. So from left to right, this graph decreases, and then it increases. And this is a parabola. So right up here, it opens up. Okay, I'm going to scroll and show you the filled-in answers so you have a chance to double-check yours. But right now, I'm going to erase this graph and move on. If you need to pause here and finish your notes, then go ahead and do that. All right, let's scroll. Here are my answers. Everything right in this exact same order that we wrote them on the graph. Parabola, the x and y intercept, the vertex, first and last values for x and y, decreasing, increasing, and opening up. All right, we're going to grow up one more graph, and then we're going to talk about something else very briefly. So stay patient, stay strong. All right, we're going to do y is equal to the square root of x. It's a new function for us to graph. It's right here. All right, let's think about square roots. What would be possible input values for this function? Anybody ever take the square root of -4? I don't think you ever have, because it's just not mathematically possible. Not right now. We'll be in Algebra 2, but not now. So what would be possible input values for this function? Well, I can take the square root of 0. So I could put in a 0, and then I could put in any positive numbers. So all positive numbers. So that means what I can't put in to this function, what would absolutely not work? Negative numbers. I can't put negative numbers in for square roots. All right, if you've got your calculator, your TI-84, what you were putting at y equal is, you press the y equal button, and you're doing the square root of x, and then you're going to scroll up and down and fill in your table, and what you're going to see almost immediately is that if I put a negative number in, I'm going to get an error here. The calculator says you can't do that. So the square root of -4 is going to give me an error. The square root of -1 is going to give me an error. And the square root of 0 is not going to give me an error. The square root of 0 is 0. Now I'm going to graph this thing, and I get to pick numbers. So I'm going to pick nice numbers that graph really nicely for this. So I can do the square root of 1 because that's going to give me a 1. That would be a nice graphing number. The square root of 2 is going to be irrational. The square root of 3 is going to be irrational, but if I put in the square root of 4, so if x is equal to 4, that would give me a nice 2. That looks like a good number. So I've got the same issues with 5, 6, 7, and 8, but if I put in a 9, that's going to give me a 3. That's a good number. So you can see the pattern. Now I've just about hit a problem with my grid, but let's go ahead. If I put a 16 there, so if I went that way, I'd still be okay on the y's because there's 4, but I don't have an x value out here at 16. So we're going to stop graphing this right here. We're going to join this together in a nice continuous curve, so it's not going to matter that we don't have a million numbers to plug into it. We know what it's going to look like, or I do anyway. All right, so my first is 0 and 0. Let's go ahead and put that one in. My next one is 1 and 1. Then I've got 4 and 2. And the last number that will fit on this grid is 9 and 3. All right, this is a function. If I graph this in the calculator, I get a nice smooth curve, and it looks like this. And because the grid goes on forever, I just can't see it. I'm going to put an arrow on the end. So graph that. And now we're going to move on to the description. Again, if you need to pause while you graph that, go ahead and do that. All right, what shape is this? This is definitely not a parabola. But if I put this, if I have my imagination at work, if I did that, what I actually have here is a half a parabola. And later on, well, we've talked about things being squared and the opposite is the square root. So now you're starting to see what the relationship is. So the shape of this is a half parabola. You can go ahead and write that down while I erase all this stuff. And now you know that the next questions are going to be about the x and y intercepts. All right, so let's mark those in that color. All right, right here, I've got the x-intercept. It's also the y-intercept. And that ordered pair right there is 0, 0. Remember, the vertex was the highest or lowest point on the graph. So this is also the vertex. So it's also 0, 0. All right, and is there a maximum or a minimum? Well, we have a vertex, we have a lowest point on the graph, so we have a minimum, and that minimum is that y is equal to 0. Because up and down, which is where we find maximum or minimum, that lowest point is where y is equal to 0 on that graph. All right, does the graph have symmetry? Absolutely not. There's no way I can fold that in half and get a mirror image of exactly the same, or that looks the same. All right, where are the first x value and where's the last x value? So let's clean this up a little bit, not too much. Hopefully you're getting the hang of this at this point. Moving from left to right, I'm looking for my very first value for x. And my very first value for x is not until all the way over there. And that first value for x is actually 0. And if I keep going along, there's an arrow. So my last value for x is infinity. My last x is infinity. My first x was 0. Okay, let's clean some more of this up. Wish I could make the eraser bigger. Okay, we find the values, the first and last values for x by reading from the bottom to the top. So go ahead and start moving along your graph from the bottom, start moving up. You're looking for the first place where the graph starts. And there's nothing down here in quadrants 3 and 4. There's no part of that graph down here in quadrant 3 and 4. So if I look at this from down here, my very first value for x is right there. So my first x value is, or my first y value, these are the y's. The y's are going from bottom to top. My first y is at 0. Keep going up here. I don't have any y's here, but if I go this way, there's my last y. And it's at infinity. All right, now what happens from left to right with this graph? It's getting sort of junked up, so let's clean it up a little bit. We're going to figure out, as x increases, is y decreasing or increasing? I think you probably can answer that question already. Remember, everything is from left to right. How close will it let me get? There we go. All right, so from left to right, the x's are going along and increasing, and this is what happens to the y's. The y's are going to do nothing but increase. So you're filling that in. Now, this is not a parabola, it's half a parabola. It's sort of lying on its side. So does this graph open up or down? This graph does neither one. It doesn't open up and it doesn't open down. One more page. But first, I'm going to let you look at the answers that are all written down here. Here's everything that describes this graph. Half a parabola, the x and y intercepts, the vertex, where the minimum was. All of this is here. And again, like I said, there'll be a solution sheet probably tomorrow that will show you all of this as well, because the practice is also, the solutions for the practice are in the same document, or the solutions for the same document. All right, one more thing. We're going to take this part about, is the graph increasing or decreasing, and we're going to take it one step further. We have something here at the top that is called algebraic notation. And it says, many times on standardized tests, you will be asked to describe a specific area of a graph. The notation to identify the area to be examined is called algebraic notation. And it looks just like inequalities, and I'm showing you a graph there so you can read it. Basically, what it says is this, when you encounter this, it wants you to describe what the y values are doing. And this is how you read it. It says, between -2 and 5, that's where the x is, -2 and 5. What does, see, is that working? There we go. So given the x's, and it's a range, what's happening to y? Is it increasing or decreasing? And it could be doing nothing, but typically we're talking about increasing or decreasing. I'm going to read it to you because I know it's hard to read this. All right, so we have a range of x's between -2 and 5. Given that range, we're going to look and see what the y's are doing, and we're going to say, is it increasing or is it decreasing for that piece of that graph? This says just look at this piece of the graph. So we've got some examples here. Let's erase this. Scroll up a little bit. All right, for the given interval, state whether the graph is increasing or decreasing. Just exactly what I told you to expect. All right, our first interval for this graph is, I want to look between, where x is between 5 and 7. So let's get a nice yellow and take a look at that. All right, this is where x is 5, right here. This is where x is 7. What's the graph doing right there? It's increasing. All right, now I'm going to look at the next interval. This time it says, what's happening to that graph where x is between 8 and 9.5? So here's 8, and here's 9.5. What's it doing there? It's decreasing. Easy enough? Okay, this is the same graph that we had on the front. So let's take a look at that. We've got more intervals. All right, where x is between -1.5 and 1.5. So that's right here and right here. And what's it doing right there and there? It is decreasing. Okay, 2 more intervals. I've got 2 and 3.5, so 2 is right here, and there's 3.5 is right here. What's the graph doing right there? Increasing. One more on this graph. Between -3.5, which is right here, and -2, which is right here, this graph is increasing. Okay, let's go ahead and I'll let you write down anything you'd like there. There's one more. Always pause if you need to. Last one. For the given interval, state whether the graph is increasing or decreasing between 0 and 4. So where is x0? It's right here. Oh, I've got to put it back on the pen. That's right here. And -4 is right here. Oh, excuse me, we're going to 0 to +4. That's right there. So in those two, between there and there, that graph is increasing. And between -4 and 0, which is here and here, that graph is also increasing.
Third lunch, dine-in, Blue Day, report to the cafeteria at this time.
Again, that's what lunch is like over here. All right, so what can we say about that? That graph doesn't increase or decrease the up or down. Actually, let me restart again. That graph doesn't go up and down. Along its entire length, that graph does one thing and one thing only. From this end to this end, those y values are always increasing. They don't do anything else. So, thank you for your time. Hope you're following the lessons okay. And you'll have 2.2 up next. Bye-bye.